Unit 9, Lesson 2, Simplifying Radicals and Rational Exponents. So this is going to build off Lesson 1. We are going to simplify radicals and rational exponents and not just evaluate them. Okay, so just remember from the first lesson that the nth root of x is x to the 1 over n, so you can write roots as exponents if you put a 1 over that root. All right, so what we're going to do is we want to list the perfect squares 1 through 20. So what a perfect square is, 1 squared is 1, 1 is a perfect square. 2 squared is 4, 4 is a perfect square. 3 squared is 9. Okay, and so on. So go ahead and list these through 20. I'm going to stop at 12. That'll be good enough, but you get the gist. So 12 squared is 144. It is also helpful to know what the square root is, so that 36 is 6 squared. Okay, so what I'm going to do is I'm going to simplify radicals using these perfect squares. So you're going to want to keep this list handy. All right, so for example, the square root of 50. So first of all, I want to know, is 50 a perfect square? So I do square root of 50. No, it's not a perfect square. I don't get a whole number. But is there a number, a perfect square, that goes into 50? So I'm going to look at my list, and I want to start towards the bottom. So when we say go into, it divides into. All right, so obviously it has to be smaller, but 49 can't go into 50. You can't do 50 divided by 49 and get a whole number. So I'm looking through, I'm starting at the bottom, and all right, I see, okay, 25. So, 20, here we go. Okay. 25. So I'm going to rewrite the square root of 50 using 25. So I'm not changing the value at all. So 50 is 25 times 2. So I'm going to write the perfect square first. I'm going to write the 25 first. Okay, now properties of radicals say I can separate these. So then I have square root of 25 times the square root of 2. Then the square root of 25, that's a perfect square. So I can write this as 5 square root of 2. So the square root of 2 I can't do anything with, but what I could do is take out that 5. So simplifying your radicals are like reducing a fraction. Like 1/2 is equivalent to 3/6. So 5 square root of 2 is equivalent to square root of 50. They're the same value, it's just a way that we reduce it. A square root of 18. So the perfect square, so the one from my list, that goes into 18 would be 9. So I'm looking here on this right side, this list here, and I go bottom to top. So the biggest perfect square that goes into it would be 9. And this is 9 times 2. So then I can separate these, and I get 3 square root of 2. Next to, like 3 and the square root of 2 are next to each other, that implies multiplication. Okay, square root of 32. All right, so I want the biggest one that goes into 32. So pause this and try this one. Okay, so the biggest one that goes into 32, the biggest perfect square, is 16. It's not always going to be times 2. These examples just happen to be that way. So then I separate this, and this is 4 square root of 2. Now, some of you might have thought 4 was a perfect square that goes into 32, which it does. So if you had written 32 as the square root of 4 times 8, okay, and then you had this, and you get 2 square root of 8. Well, that is equivalent, but that's not fully reduced, because 8 has a perfect square that goes into that. 4 can go into 8 as well. So this is like reducing, but not reducing enough. So like 4 over 8, you reduced that to 2 over 4, but then that 2 over 4 can still be reduced to 1/2. So that's why we always say pick the largest one. So start at the bottom of your list to get that 16 there. Okay, so we don't want to do that because that's not fully reduced. Okay. All right, square root of 45. So try this one, pause it and try it. Okay, so this is 9 times 5. So 3 square root of 5 is my answer here. Okay, these are the same thing, so let's keep working. So pause it and keep working. All right. So I want to start with the biggest one, which I think we find is 36. Yep, 36 and 3. So 3, 36 times 3. So that's 6 square root of 3. Okay, 147. We're checking our perfect squares. So I'm starting towards the bottom of the list, and maybe I don't know what goes into 147. So I'm going to start at the bottom. So 121, 100, all that's too big. Maybe I try 81 first. Nope. Now I'll try 64. So I go up, 64. No. Okay, go up to the next one, 49. And there it is. So 49 times 3 it was. So this is 7 square root of 3. All right. Now I have this rational exponent. So the first thing I'm going to do is write this as a root. So I'm going to write this as a square root of 84. Okay, then I'm going to go and do find the perfect square that goes into 84. Let's see. 36. Nope. So we just keep checking, keep checking. I think we're going to find it's actually 4. So even though 4 is pretty small, that is the only one of those perfect squares that go into it. So it's square root of 4 times 21. So we always put the perfect square first, even if that number is smaller, because that's the one that can come out. So I can square root 4 and get 2, so it can come outside of the radical. And then I have square root of 21. Okay, so same thing here. Square root of 75, because that's the 1/2. And then 25 is the perfect square that goes into it. This is 5 square root of 3. All right, this is the same thing. So I'm going to skip this one. Okay, then just an FYI reminder of our exponent rules. So when you multiply a common base, add the exponents. When you divide a common base, subtract the exponents. When you do a power to a power, so this power to this power, you multiply the exponents. So if you have one exponent inside parentheses, one outside, you multiply those together. All right, so we're going to practice that real quick here. So I'm adding this common base, multiplying this common base of x. So I add the exponents. So that's x to the 2/3. That's my answer. Here, I'm dividing, so I'm going to subtract. And it might be just as easy to type that in your calculator, because some of us don't really remember fractions. You know, to subtract fractions, you need to get a common denominator. That takes a little bit of time. So it's really, sorry, this calculator. It's really easier to just type it in. And it's always top minus the bottom. So I get -3/10 here. And we're just going to leave that as is. The negative exponent, remember, means 1 over. So really it's 1 over x to the 3/10. The negative exponent means that it has to move to the denominator. Okay, power to power, so 1/4 times 3, so type that in, 1/4 times 3. You should get x to the 3/4. All right, and then we'll look at this one. So lots of things we have to do here. The first thing is I see this exponent outside of parentheses, so I'm going to distribute that to both bases, and I multiply the exponents. So that's going to be x, and I'll do 1/4 times 2, which is 2/4, and then y to the 4th, 2 times 2. And then this x to the 1/8, there's no operation, so that's implying that that's multiplication. Okay, so I want to do that first. Then I'm going to combine my common bases here. So I'm multiplying here on the top those x's, so I'm going to add those exponents. The 2/4 does reduce, but I want to wait to do any reducing until after I've combined and got all my bases together. Okay, so you're going to do 2/4 plus 1/8. Again, it's probably just as quick for you to type that in your calculator. Unless your calculator is not working good like mine. It's not liking the buttons that I press. So we should get 5/8 when I do 2/4 plus 1/8. Okay? Then I have this common base of y, so I want to subtract the exponents. So you subtract and put it in the numerator, and then if it's negative, you can move it to the denominator. So then 4 minus 3 is 1. So that's y, or you can write that as y to the 1st. And we're going to look at a couple more of these. So pause, work these out, and then you can check your answer. So I'm going to distribute the exponent outside. So that's 2 to the 4th. And I'm going to go ahead and evaluate that because those are both numbers. So 2 to the 4th is 16. Okay, over 8. X is 6, 1/2. Okay, so 16 and 8 are regular numbers. So I'm going to do the regular operation here, which is division. So 16 divided by 8 is 2. And so 2 is on top.